does, we will go through that. Okay? Everybody got that? Now your test tomorrow is going to be like the first test. It's going to be a one-day test, so you'll see the FRQ populate. I'll give you answers to like usual. Okay, so for question 8, it asks, what is the empirical formula of an oxide chromium that has 48% oxygen by mass? So remember, that's really pretty much your empirical formula is the percent by mass of each element, right? Because it gives you the mole ratio. So what the easy way to do this one is you can just go through one of the choices, find the one that's 48% by mass. So if you quickly look, one is like 52. Okay, don't use all the numbers. It's multiple choice. Okay, so I know that's 52 plus 16. That is not, quickly looking at it, that is not 48%, right? You'll see that? So I can eliminate choice A. Let's look at choice B. That's still 52 plus 32. Does that look like it's close to 50%? Maybe. You can calculate it. Y'all see what I'm doing? Okay? This is how we do it without a calculator. So 52 plus 48. Does that look like 50%? Y'all understand that? Okay, so you really didn't have to do a lot of math, but you could do, this is where mental math comes in. So anytime you have multiple choice, don't use all the sig figs, just use the main numbers, and that will save you time. But it also, but my question for you is this, even though I showed you a shortcut, do you understand why I did it the way I did? That's what I'm trying to get to. You understand why? Yes? Okay, because it does ask why. Okay. All right, so what was the other question? Number 9. Number 9 is typical type question where they give you a data table and there's a lab. We know we have a metal that reacts with oxygen, and given the information table, what's the most probable formula for the metal? So we know it's something and oxygen, right? And so all these have 1 or 2 oxygen. Okay, so we need to figure out what we have. So if you subtract these two, what are you finding? So how many grams is that? 5 grams? 5 grams of my metal. I'm calling it M. Or you can call it X. I don't care. And if you subtract, depends on what you subtract next. When you subtract between these two, what are you getting? Yeah, your 2 grams of oxygen. Have I got that? 2 grams of oxygen. So, given the information in the table above, what's the most probable formula for the metal oxide? Well, remember, these are mole ratios. This is a 1 to 1, 1 to 2, 1 to 1, 1 to 2. So I need to look for mole. You see what I'm saying? So based on this, I know if I take 2 grams divided by 16 is 1/8. So what is 1/8 in 0.125, right? 0.125 mole. Okay? Is everybody following so far? Yes or no? Are we good? Am I losing anybody? All I did was find moles. Now, I don't know grams of metal, but if I take 5 grams, divide by the molar mass of magnesium, which is around 25, right, or 24, okay, what is that mole ratio there? It's about 24.5. So what's 5 divided by 25? 1/5, which is 0.2. Is that ratio 1 to 1? No, so I can eliminate A. Okay? You try B and tell me. Okay? There's other ways to do this too. Do the next one. 5 divided by 40, what? Is that close? Great. So this is one way to do it. Did y'all get the same ratio for B? Yes. So the answer is B. Okay, that's one way to do it, because you know the mole ratio. The other way to do this is, that's the easiest way for y'all to do. Okay, are y'all ready to go? Okay. You understand my thought process, okay? Remember, empirical formula is the mole ratio. Okay. What's the other part? Remember you. There it is. They give you, this one is a little bit harder to do, but I think this is how I solved it. I knew 1.6 grams of X is what I'm given, and I have 3.8 grams of fluorine. So, the nice thing about this, since it is mental math in a sense, fluorine weighs how much? 19. Okay, since y'all use calculators, I won't do this all the way. It weighs 19. So for me, what I did is I changed this to 38 grams and I changed this to 16 grams. But if you want to go and take 3.8 grams divided by its molar mass, 19 grams per mole, what do you get? 0.2, okay. This is 0.2 moles. And then this one, hold on. Oh, and there's, I forgot there's 4 of them. So there's 4 of these, right? So what's 0.2 times 4? 0.8. So something's going to be close to it's going to, so that means X is 1/4 of that value. Okay, did I see what I'm doing? So, if this is 0.2, this will be 0.8 moles. This is for my X, this is for my X. I don't know, okay, so what am I looking for? We don't know the common element of X is likely to be. So, which one of these is 4 times as much? Hold on, that's not how, I did it differently last time. I know somebody does it easier. Just solve for X. What point? That would be correct, right? Solve for X. I did different numbers last time. What do we get for 0.8 divided by 0.2? What's 0.8 divided by 0.2? Oh, 4. So, differently for y'all because it's actually hard for most people. 3.8 divided by 19 is 22. Oh, I just gonna do it this way. What's 19 times 4? This is probably the easiest way. What's 19 times 4? 76. So, one, and we know that the mass of this is going to be one fourth of it. Okay, so the X mass of 1/4. Okay, did y'all someone else sign? I can't think this one. What did you do?
I did 19 times 4.
That's 76.
And then it said that the compound is using 1.6 grams of X.
Oh, I forgot to do the 1.6 grams. That's where I left off.
So I
Okay.
did 76
Divide by 1.6. Oh.
76 divided by 3.8 to figure out how many fluorine atoms or something there was, or kind of like what the ratio is. And I did 1.6 times 20.
You did 76 grams.
So that's how many there are. And I did
Oh, so this is your grams of fluorine.
yeah, I times it by 4.
Okay.
Because that gives me the total amount. So then I had 76. And then I did 3.8 divided by 76. Because it gave me like the ratio to use. And that gave me 20. And then I did 1.6 times 20. And that was 32.
Okay, you don't understand what she's saying. Okay, not much.
You guys are working.
1.6 grams. I forgot to use this. That's probably why I didn't. Okay, does that make sense for every? Okay. So she knows the grams of fluorine is going to be 19 times 4. Okay. Okay. And so to find the ratio of that, she took 76 divided by 3.8 grams.
How much of that
Yeah.
there was.
So whatever that came out to be, we said that was 20. Okay. So in a sense, that's 20 moles. For every 20 moles, it is there's 4 atoms for every one of the X, so that's 5 times. Okay, so for every 4 of those, we have 1 X. You know what I'm saying? So if you have 20 moles of F, that means you should have 5 moles of X. Does everybody see what I'm saying now? So there's 5 moles of X. What's 5 times, well, I guess that's the same, 1.6 times, we 65 give me 5. Give me that ratio. That would give me the max. Because that's what I did here is divide by how much I have. Okay? Does that make sense?
Did you find, like, convert the 3.8 grams of fluorine to grams and divide that by that atom?
Yeah, you did. So, if I take 19 times 4 at 76, I divide by what I have. So I know in my F, there's 20 moles of it. That means I should have 5 moles of X, right? Because it's 1/4.
What is the 19?
The molar mass of fluorine.
Oh.
Okay? So here I know there's 20 moles of this. There's 20 moles of this, so there has to be 5 moles of X. If I know I have 1.6 grams of X, which is what I forgot to use earlier, I take my 1.6 grams. I don't know what I need to divide by the molar mass, because remember I divided by, I need the molar mass, and then I know the ratio is 5. Okay. That's one of the more challenging ones. Are we good? Or you can take You could do that as well.
But also send out the stuff before.
Yeah, that's what you could do 1-to-4 ratio that way. I didn't know it would be easier. This is one that always gets tired because I forget. Okay, let's move on to FRQ number 4. Does anybody have any more multiples before we move on? Do we? Okay. Honestly, you probably won't have anything like this on your test. You'll have things like this. This practice is way harder than the actual test. And I think these are the actual exams. Okay, no more multiple choice. This one y'all can skip for now. Did it say omit on y'all? I want to double check that one. Did it say omit? Okay, good. Now, as far as free response goes, this is a typical free response. Are there any questions? And did you see how it leads you into the next problem? Did I see that? Does anybody have questions on how to find A and how to find B and C? Because I'm supposed to go all the way to F, which I may need some of the answers from the beginning. So, determine the mass of grams. How did y'all find A? Quickly, just tell me how you would do it in terms of answer. And subtract it. Yeah, the thing I taught you about combustion analysis, right? You know what I'm saying? So you will do 6.8618 grams divided by its molar mass. And then the ratio is 1 mole of carbon for every 1 mole of CO2. Then you multiply by the molar mass. And then that will give you, what's our answer there? 87? Can you give me one more digit? See how many things there are? 2, 4, 8, 2, 5. Okay. Are we good? So this is grams of carbon. Okay? How would you find your grams of hydrogen in B? You do the same thing, but remember, water is what gives us H2O. So you do the exact same thing, but this time you need to remember it's 2 moles of hydrogen for every 1 mole of water, and then multiply by monatomic hydrogen molar mass. Okay? So you do the same thing. 3.8625 divided by its molar mass. 18.02. Is everybody good with all what I'm doing? Determine the mass in grams of hydrogen. And that's just the sample. Wouldn't you just subtract it? I don't have that. I would use 1.757. Sorry, I used the wrong value. 1.7557. There we go. Is everybody good? Sorry. Yeah?
Why would we use the other masses when it says in the sample of the compound? Why don't we use that?
Okay, so for this particular problem, our compound has carbon, hydrogen, nitrogen, and oxygen. So this is the mass of my compound. X, Y, Z, and W. Okay? Does that make sense now? So now we know we will use this to get our carbon. We'll use this mass to get our hydrogen, and that's where I just wrote down over here. Okay? Does that make more sense now? Okay? Is everybody good? So now that you have your grams of nitrogen and not nitrogen, carbon and hydrogen, part C, probably you have to subtract something. Oh no, here is, they tell you 14.14% is nitrogen, so to find the grams of nitrogen is take the 14 times the mass of the compound, and you get some answer. That will give you your grams of nitrogen. Does everybody understand how we got that? Okay. And then how do you find the mass of oxygen? subtract everything that you calculated beforehand from the 3.865.
So if you find the nitrogen, multiply the 14% times
The sample.
and then that's it.
That's it. Yeah, because it tells you that sample contains 14%. So you know, out of all that has to be everything else. Is everybody okay with that? So we got D done. Am I going to that? D, okay, so now define the empirical formula. Remember, take the mass of your grams of carbon, your grams of hydrogen, your grams of nitrogen, and your grams of oxygen. Do the empirical formula process. So tell me, what is the empirical formula process? What should you do? You have grams. What should you do first? Moles. Find moles. So after that, what do you do after you find moles? Okay, you divide by the smallest. Remember, it's moles. Don't round too soon. Add an extra big if necessary. And then what should you do next? Round to whole or multiply by a factor to get to whole number, right? So what is our empirical formula end up being? C 4 H5 and O2. And that is an empirical formula. Can I reduce that down any further? No, it is reduced down. So is everybody good on? I didn't do all the steps from empirical formula. Are y'all okay with that? If you don't, I'm happy to do it. Okay, so now we have that. So let's get to F. Okay, so in another experiment, it's determined that you have this many grams of a compound with this many molecules. Molar mass. What is the unit for molar mass? This is what you need to remember. What is the unit? It is grams per mole. So you need to find the amount of grams. Okay? So, well, actually you have grams. And so now you need moles. Has everybody got that? This is your grams. You have that. So we need to find this. I don't know what this is. Okay. This is the one thing I don't know based on this problem. So if you're given molecules, how do you find moles from that? Divide by Avogadro's number. For 1 mole. And once you get that, that'll be the number here. Does everybody see what I'm saying? So then you'll take your 8.65, divide by the molar mass of whatever that. What is the, how many moles did we get? How many molar mass did we get? 1. Okay, does everybody understand we got moles? So calculate 8.65 divided by the moles. That would give you the molar mass. So the answer is 298 grams per mole. So how do you find the molecular formula? Remember, the molecular formula is either the molar, empirical, or a multiple of it. So all you have to do is find the mass of this. So the mass of that is 48 plus 5 plus 14 plus 32. What does that come out to be? 90? 99?
Is that the empirical?
This is the empirical mass.
Yeah.
Okay, so 99. What's 298 divided by 99? 3? Is everybody okay with that? So what is the molecular formula then? C12, 15, and 306. If you find the molar mass of that compound, it's going to come out to this. Okay? So, questions on how to find the empirical and molecular mass? Okay. Does anybody have any other questions on this practice test or throughout the package? Okay, so your test tomorrow is focused on anything with moles, that means with ideal gas law and just molarity. I'm not doing anything about the properties of gases or solutions. So there's moles. You need to be able to find empirical formula, understand how to find average atomic mass, read the graph on average atomic mass. I think that's it. And then as far as mixtures go, that's pretty much it. Always find the parts in mass and then.
Do you think the test will have questions on packet or
The real test or my test? My test is always easier than the review. Okay, I over prepare you for the test. Okay, the only drawback is that you don't have the luxury of taking your time and catching up and pace yourself. So this is what I'm saying. Know the process. Know. I mean, I know. I always ask you what's the definition. It's because I will prompt you. Find moles. When in doubt, guys, find moles. I swear, moles will probably be for you. You don't know where to go. Look at your data. Oh, I can get moles from here. They will always ask you moles. Okay? By many means. As far as finding actually finding an empirical formula, I have not seen that on FRQ in a while. But it is in multiple choice. Okay? But it's still based on mole ratio. So that's what I was trying to tell you. Just use simple moles, whatever you need to do. Okay? Does that make sense to y'all? Like I said, I do think this practice is way harder than your actual test. You just have a time test. Any questions? And then after that, we will go straight into Unit 4, which is chemical reactions. Okay, so learn about moles, we'll do reactions. Okay. Now we'll do the stoichiometry. Anything that has to do with stoichiometry, I did put on the test. Okay, but I'd still expect you to know how to do ratios of elements and atoms within a molecule. The only one that's really the stoichiometry that we have done is pretty much the combustion. Okay. So I got that. Y'all want to look at your quiz from yesterday? Did y'all get to look at that yet? Okay. We'll do that in the remainder of time. I'll go ahead and as far as all the grade drops, I will take care of that Friday, okay? Because I think Friday. And I'll try to get the test graded by Saturday. So as far as yesterday's quiz goes, I'll take off the lockdown browser. That way you don't have to close out all your No, I'm taking off lockdown browser. Okay, I'm not giving you the correct answer. I would like to you're trying to figure out the correct answer. So you're welcome to look at your quiz now. It should be open.
It doesn't tell us which one we got wrong.
What?
It doesn't tell us which one we got wrong.
It should, I have it checked out, indicate response as correct or incorrect, and now look at the point value. I don't know why that's not working.
Oh, the point.
Is it working now?
Yeah.
Okay. It could be just delayed. Yeah, okay, that's what
There's this one kid and he's like obsessed with it, and he wouldn't do anything until somebody gave him an orange pie, and then I'm like, I was talking to the Jersey person, and I was like, this is orange? And then there was this kid with orange hair. It was like he was a He's terrible. Enzo I had to like chase Luke and Enzo down. They started running away. You push the lever One bound. 2 bounds. 3.
think Berlin.
I think that was fair. Okay, four.
Yes, ma'am.
Yeah, five. Okay, six. I found
She said something about interesting, but
what else is the yeah, you need the formula. Okay, you're trying to identify. If it's soluble in water, you know you can identify the element, what element is present. Does that make sense? The density of the pure compound does not tell you what is in the elements in the compound. It just tells you what is the elements in the one of them will be in HCl. It doesn't really matter I need zero. Okay,
Pearly and black.
the other thing that the other test is giving you
Yeah, it's something.
identify which compound is elements analysis.
if you don't lie about it,
Yes, molecular analysis is. Oh no, it's just.
I mean, she like lies.
It's like if I said you have 100 dogs, how many legs does 100 dogs have? Yeah, that's really what it's asking. So it's always the whole leg within the other thing. And then once you get to this, you know, you always have to because I don't know. Okay, does that help? Yeah. This is the key. That ratio. Yeah, you do 4 moles because there's 4 here. If it asks for hydrogen, no, if it asks for hydrogen, if I ask for hydrogen, I'll be to the whole thing. It's like underdogs for you know. Yeah. Now, how many moles are present in molarity? Okay, so my hint for you is, no, this is like molarity. So we're doing the root of molarity. Just make sure we're this right here? Yeah, it's on your it's written like this. I like the other one because in
Okay, I think before practice we should do like the and then like when we're getting ready, just like dollars.
Okay,
Probably what unit or car. Yeah. It's a nice Montgomery's desk. Why are you doing that? No, that's
Because we cannot.
Wait,